Okay, so today's daily Leetcode problem 248b, minimum penalty for a shop. I already read the problem statement and I have one idea how to solve it. So the problem statement is as following. We have customers coming every hour, and if there is Y, the customer is coming in this hour, and if there is no, it means no customer is coming during this hour. And I should decide which hour should be used to close. And here, let's say if I close an error, I have a penalty if I open and no customer comes to no customer comes, then I'm gonna pay the penalty of +1. And if I enclosed and customer comes, then I'm gonna pay penalty also 1. So my idea is initially and the output should be like what the earliest hour I should close the shop to incur the minimal penalty. So my idea is like to have the pointer approach. So let's say take this for the given array we have y, say y and then y and then n and then y. So I'll calculate number of y's from the like whatever, like in this array. So there are 3 y's. Let's say I start like I have one pointer approach, and I say okay, I close at hour 0, and then I'm gonna move a pointer, and it's gonna be the close time, and it's gonna be from 0 up to 4, like, so I can stay like the entire time in the business. So let's say I close at hour 0. In this case, the penalties gonna be number of yeses to the right. So number of yeses to the right is 3, so the penalty is 3. And then let's say penalty is 3, yes, 3. Let's say call it right yes. So I'll calculate right yes equals 3 and left no equals 0 initially. And the penalty gonna be right yes plus left no. So in this case the penalty gonna be equals 3. And then I move the pointer to the index 1. And because the previous one was yes, it means that I'm decreasing number of yeses in right yes. And now I calculate again the penalty. I is equal 1, the penalty gonna be, so it was here penalty 3, here gonna be penalty 2 plus 0, so it was 3, and then now right yes equals 2, and then left no equals 0. So the penalty gonna be 0, and then I move I is equal 2, and then I check, okay, what was the previous pointer? It was yes, so I decrement number of yeses on the right, so number of yeses on the right is gonna be 1, and then left no is gonna be 0, and then penalty in this case is gonna be 1. And then again I'm moving the pointer, so it was before on n, now it's on y, so I is equals 3, and then when I moved it was staying on no, so I should increment the left no's, and it should be 1, and right yeses should be also 1, should stay 1, so the penalty becomes 2. And then I move I to 4, so it's already out of the bound. So it was yes, so right yes becomes 0, and left no stays 1. and then penalty becomes 1. And then I record like whatever was the lowest penalty and whatever was the hour. So the first lowest penalty 1 was at hour 2, and this one I should output 2. This is gonna be the answer. So yeah, so it's gonna be so the time complexity of this algorithm gonna be O of n TC, and the space complexity gonna be O of 1. I'm gonna go through the array twice. First time I'm gonna just calculate the number of right yeses, and then I'll move the pointer from left to right, and then I'll gradually like assume that on every position I'm gonna close the store, and then I'll recalculate the penalty and like adjust the minimal penalty. So I'm gonna go so right, left, right yes is gonna be, how's it called? Right yes gonna be equal sum, and here for C in customers, then here if C is equal yes, I'm gonna have 0, 1, else 0, 0, and then I'm gonna go move the pointer 4, and then gonna be left nose gonna be equal 0, and then mean penalty gonna be ry, and then mean hour gonna be 0, and then for I in range one to len customers, I'll do reconstruct the invariant. So if customers I minus 1 is equal yes, means that ry minus equal 1. If customers I minus 1 is equal no, or I can just use no else, and here, okay, let's keep it as it is. Now if, then it's gonna be left nose gonna be plus equal 1, and then I'm gonna have this if mean penalty is greater than ry plus ln, I'm gonna have this mean penalty equals ry plus ln, and then mean hour gonna be equal just I, like this, and then I'm gonna return mean hour. Okay, let's run this and check how it works. Here, else, how to throw in Python, throw error in Python, raise, okay. Else raise unreachable, unreachable state. Okay, let's run it. Mm-hmm. Okay, so here also len plus 1. Yep. Yeah, so that's it. Let's check the tutorial, what they have here. Two-phase phase passes. Okay. One pass. Okay, even one pass can be possible here. Okay, so like there is solution with one pass, and it says okay, as soon as there is oh yeah, so actual plan, so at least I can do something like this. I can forget about this one. Okay, as ry is equal 0. That's very smart actually. So the starting point doesn't actually matter. What matters is like to find the minimal. And if the current one gonna be minimal, that's great. It might be like growing, or it might be decreasing. And if it's like decreasing, the penalty is decreasing. It means that I need to find it whenever it's gonna be the lowest one. But if it's increasing, I already have like the lowest point here populated, and I'll return this in the output. I wonder what's going on here. Okay. Score. Okay. If I remove this one, and I'll do this one. Okay, let's have this new penalty. There's gonna be new penalty. Gonna be new penalty. If it's greater than new penalty, then I'm gonna reassign a new penalty equals 0. I wonder if I can make it somehow. Yeah, it's local decision. I was thinking about list comprehensions, but yeah, that's also a good one. Okay, I'm gonna wrap up.